Hello everyone. So the next experiment in this light runner kit is optical add-drop multiplexer. So optical add-drop multiplexer, OADM. So optical add-drop multiplexer is something if you want to add, if you want to add or you want to drop any signal from a multiplexed signal. Okay, so suppose that you have multiple wavelengths in a signal, lambda 1, lambda 2, lambda 3. Okay, multiplexed signal is this. Many signal has been multiplexed to make a one signal, and it has been sent, and you want to add one more wavelength here. Okay, so you can do it with the help of fiber brackets grating and one circulator. So you want to add it. So suppose that is lambda 2, lambda 3, lambda 2, lambda 3. It is coming from here, and you are adding with OADM. So at this end you will get lambda 1, lambda 2, lambda 3. So one signal has been added. And if you want to drop any signal from this multiplexed output, okay, so if you want to add or drop, suppose that you have lambda 1, lambda 2. So from this OADM you can drop one, suppose that lambda 2 or lambda 1, and rest of the other lambda 1, lambda 2, lambda 3, lambda 4, or whatever the signal is, it will be passed. So you can add or you can drop one signal with the help of fiber brackets grating and this circulator. So I will show you how to add and drop this signal. So first I will show how to drop any signal from a multiplexed signal. I will take a signal with the help of this multiplexer. I will take multiplexed signal. Okay, I will use multiplexer to generate a multiplexed output which contains two lambdas, which contains two signals. One is 1510 nanometer, one is 1550 nanometer. You can take 1530 also, you can take 5070 also, you can take four signals also. And I have given it to the multiplexer. So now I have multiplexed output. So it contains 1510 and 1550 nanometer light. So two signals which are multiplex signals here. So now I will drop one signal. Okay, so I will drop. So now what I am doing, this multiplexed signal which contains both the signals, I will give it to the port 1 of the circulator. From port 1 of this circulator it has been given. So this is like this. So this is my multiplexed signal, which is lambda 1, lambda 2, 1550 and 1550, 1510 combined. So I will give it to the port 1 of the circulator. The whole signal will be gone to port 2, and then this port 2, the same signal lambda 1, lambda 2 comes here. So now this fiber brackets grating is here. So fiber brackets grating is tuned to lambda 1, that is 1550. So all other, suppose that it contains multiple wavelengths, so all the other wavelengths will be passed. So here it is only lambda 2. So if more wavelengths will be there, so that will be passed. But lambda 1 will be reflected. Lambda 1 will be reflected. So it comes back at port 2, and it will get it will work as a input, like an input to port 2. So any input to port 2 will go at port 3 because this is circulator. So this lambda 1 is reflected back and gone to port 3. So you will get lambda 1 here. So this signal has been dropped. Okay, all other signals has been passed. So this is dropping of the signal. So you can see the signals here also. You can check that lambda 1 is available here also. You can check from here. So I will take cable and I will see that combined multiplexed signal is available at port 2. So I will get this signal to the fiber brackets grating input. Okay, fiber brackets grating input. Now I will see what is at port 2. So at port 2 it should be 1510 nanometer light, because that would be passed. So I'm checking it. 1550, 1510, 1550 full. This is an alpha full and start. So I'm getting the signal. Suppose that to differentiate, I just duty cycle is 10% of 1510 nanometer. 1 minute. 10% duty cycle. So this is 1510 nanometer light, which has been passed through fiber brackets grating. What happens at input of the fiber brackets grating, I have lambda 1 and lambda 2. That means 1550 and 1510. 1510 has been passed. And what happens to 1550? It reflects back again comes at port 2, and this is circulator. Any signal at port 2 will get reflected to port 3. So now I want to see if that 1550 nanometer light is available at port 3 or not. So at port 3 I am connected it, start. So see, this one is 1550 nanometer. So this is this is dropping of the signal. Now I will perform how to add two signals using circulator and fiber brackets grating. So I am not using any multiplexer to add two signals. I can add in this multiplexed output also, but I am just adding two signals. Okay, I am just adding two signals. If I can add two signals, then I can add any signal to the multiplex signal. So I will take two signals and I will add it. So these are my two signals, 1510. This one is 1550. So look what I am doing. 1550 nanometer I will take and I will give it to the circulator port 1. Circulator port 1. It goes to port 3. So it goes to port 3 and I have connected port 2 of the circulator to fiber brackets grating. So it gets reflected back to port 2 and it comes to port 3 because it works at input to port 2, reflected one. So it comes at port 3. From port 3 I have taken the output. Okay, so this is 1550 nanometer light. Now I have taken this port, this 1510 nanometer. So I will just give it to the port 2 of fiber brackets grating. Port 2 of the fiber brackets grating. Why? This is a bi-directional device. So 1550 has been reflected from here. So 1550 has been reflected from here and it is available at port 3. because it goes to port 2 and then goes to port 3. And now as this is a bidirectional device, I can connect it here also. This 1510 nanometer, I can connect port 2. So this 1510 nanometer light will be passed through it, and it also goes in this fiber. Okay, from here to here it passes, because it is 1510 nanometer, 1510 nanometer. So it goes in this cable and it goes to port 2 of the circulator, 1510 nanometer light. And if it goes to port 2 of the circulator, so that signal will be available at port 3. So this 1510 nanometer light also comes to port 3. So from reflected from this fiber brass grating 1550 nanometer light, and this 1510 nanometer light passing through this fiber brass grating, it also comes to at port 3. So this has been combined. This 1510 and 1550 nanometer light has been combined using this fiber brass grating and circulator. So let's check it. Okay, both the signal has been selected. This one is 10% duty cycle, just to differentiate. Okay, so start. So this is the signal. You can see this one is 10% duty cycle, 10% duty cycle, and this one is 50 nanometer. So I will just see individually. Okay, so I will deselect this 1510 nanometer and then I will start. So this is 1550 nanometer light available at port 3 of the circulator. Okay, at the circulator here, because reflected back. And then I have taken 1510 nanometer alone, and this also 10% duty cycle available at port 3. Okay, so these two signal has been combined signal. So I have just reduced the 50 nanometer power to see properly. Okay, look at it. So these are the combined. So I have just added and I have just dropped signals from a multiplexed signals. Optical add-drop multiplexer with the help of FVG and circulator. Thank you very much.